Okay, so let's continue number 14. So we're given this system of linear equations, right, in three variables. And again, we want to determine the coefficients C1 and C2 and C3 for the purpose of finding our particular solution. Now, from algebra, we know that this system of linear equations, right, has an associated matrix representation. Right, we love matrices because we can definitely use our calculator for those, and they're fun to solve, but they do get pretty tedious the bigger the matrix is. So let's transform this into a matrix. So our augmented matrix, so remember we have this vertical bar, 0, 0, 3. So we're basically going to be using our, we're not going to be using the variables here because we don't need to. I mean, you could solve this by the addition method if you'd like. As long as you solve this system. But it's very easy just to use the coefficients here. So my coefficients are 1, 1, 1. So 1, 1, 1. 1, and then there's 2 and 3. So 1, 2, 3. And then we have 1, 4, and 9. So 1, 4, and 9. Now, in order to solve this this matrix, I'm going to be using the Gaussian elimination method, or you may have heard it as the row echelon form or reduced row echelon form. And if you remember, I mean, the goal is, I mean, there's a bunch of steps in here, and the goal is to get it into this diagonal form, right, with zeros above and zeros below. And the reason we want to do that is because then our solutions are just right here. But we're able to use our graphing calculator. So we're going to go ahead and use our knowledge of inputting a matrices in our calculator and finding our reduced row echelon form. So I want it to be in this form. So in your on your calculator, so I'm going to go ahead and just call this matrix A. And oops, I'm going to go ahead and rewrite it. Well, okay, let me go ahead and explain this first. So I have a three rows, and then I have 4 columns. So this guy is, right, my A, this is a 3 by 4 matrix. And what I want to do, let me just erase that, is I'm going to use the function RREF, which stands for reduced row echelon form, and then I'm going to input my A, and it's going to give me a nice, whoops, matrix. Okay, what's going on here? Okay, now I'm going to go ahead and write the matrix in right now, just because I don't have my calculator with me, and I actually want to do a video. I want you to actually see me inserting the different values and using matrix and math and RREF, but it's kind of hard to explain it without you actually seeing it. So I will do a video on that. But for now, when you use your calculator, or if you already know how to use it to find your matrix, right, it's going to spit out this matrix 1 0 0 0 1 0 and 0 0 1, and this is what you want, right? You want this diagonal matrix, and well, actually should put a vertical bar there. Your calculator might have a dashed line, which is fine. And I didn't leave enough room here. Let me just go ahead and write that in. Okay, and it's going to spit out 1.5. This is going to be -3, right? And then it's going to be 1.5 again. And you can always just change that to 3/2 if you'd like, if you prefer working with the fractions as opposed to the decimals. Okay, so what is our particular solution? Y sub p. Well, we found our C1, C2, and C3. There it is, C1, C2, and C3. So we know it's C1, so that's going to be, I'll just write as 1.5 e to the x minus 3 e to the 2x. Let's just be consistent here. And then we have, and this actually should be minus 3. Minus 3e to the 2x, and then we have plus 1.5, or 3 halves, e to the 3x. And that's pretty much it, unless, let's see if you want to simplify, but that's pretty much it. You found your C1, right? C1, C2, and C3. And actually, I'm going to go ahead and change this to fractions, just because if you have a different, if your solution, the back of the book is different, it's because they simplified a little bit. So if I write this as 3 halves e to the x minus 3 e to the 2x plus 3 halves e to the 3x. Okay, so again, I'm just simplifying. I mean, this is just a big fraction, right? We can find the common denominator. We know 3 is really the same thing as 6 halves. So we can write 3e to the x minus, and then we have 6e to the 2x plus 3e to the 3x. So I just added fractions, right? This guy, that's really 6 over 2. And so the book has this solution. So that's why I went ahead and changed that. And that is your particular solution. So hopefully that helps. I know it was tedious, but it was fun, I hope.